Hey again, it's Mr. Alexander, and today I want to talk about solving logarithms. And the problems I'm going to show you today are ranging from fairly basic to relatively complex. Let's start with a fairly basic one. Log base 7 of 343 equals n. On this one, there's not actually any solving to do. You just need to remember your change of base formula so you can type it directly into the calculator. Because you'll remember that the calculator only has a log base 10 button and a log base e button. There's no log base 7, but we can rewrite this logarithm base 7 so that we can type it in. Remember, change of base is simply log of 343, that'd be log base 10 of 343, divided by log of 7. And when I type that in the calculator, let's see, log of 343, and that's the common log, that's base 10, divided by log of 7, my value of n equals 3. Now that makes good sense because 7 to the third power equals 343. So that's what we'd expect. This next one right here is the exact same thing. There's no log base 1/2 in the calculator. So I'm going to use my change of base. I'm going to do log of 64 divided by log of 1/2. That's going to be my value of n here. I'm going to type that directly in the calculator. Log of 64 divided by log of 1/2. And that's -6. So what that says is 1/2 to the -1/6 power equals 64. And if you don't believe me, let's just type that in. 1/2 to the power of -6 is 64. So that's what the logarithm's telling you. So that's fairly simple. Let's talk about some stuff that's a little bit more complex, where it's not just type it directly into the calculator, where we actually have to do some algebra. So I'm looking at log base n of the 4th root of 8 equals 3/4. Well, I want to get rid of this logarithm, and the easiest way in my mind to do that, to get this n by itself, is to realize that there's only one rule in algebra, and the only rule in algebra that I care about is whatever you do to one side of the equation, you must do to the other side of the equation. So in this case, I'm going to write down a base of n, and everything in the previous step, I'm going to put up into the exponent of this base n. So I'm doing it to both sides of the equation, so it's okay. So this is the base of my exponent. My exponent for both of these is log base n, 4th root 8. So that's the exponent of that one. And the exponent of this one is 3/4. Now, the reason I did that is because this base of n and that log base n, these things are going to cancel each other out. Remember that logarithms and exponentials, those are inverses. They cancel each other out. So that goes away, leaving me with the 4th root of 8 equals n to the 3/4 power. Now that might not make you feel very good, like I still don't know what I'm doing, but when I rewrite this 4th root, maybe it's going to become clear what we're going to do next. So remember that the fourth root is the same as the exponent of the 1/4 power. And hopefully now you can kind of see we're getting somewhere here, because these both have exponents of fractions that have a 4 on the bottom. So if I raise both of these to the 4th power, then I've got 8 to the 1st power equals n to the 3rd power. So what happened here? Remember, exponent to an exponent, you multiply. So 1/4 times 4, that's just 1. 3/4 times 4, that's just 3. We're one step away now. I'm going to take the cube root of both sides to get n equals 2. And you should always double check your work. So we want to make sure that log base 2 now of the 4th root of 8, we want to make sure that equals 3/4. So let's type that into the calculator. So log of the 4th root of 8, so instead of doing the 4th root of 8, I'm going to do 8 to the 1/4 power. And we want to do the log base 2 of that, so I need to divide all this by log of 2. And hopefully that equals 3/4. It's 0.75, which of course is 3/4. So yeah, n equals 2. I'm feeling pretty good about that. Let's do another one that's, of similar difficulty. Log base 15 of x squared minus 2x equals 1. So I'm going to do the same thing here. I'm going to put a base 15 on both sides of the equal sign here. And I'm going to write the previous step in the exponent of that base 15. And now, hopefully you see that this 15 and log base 15 cancel out, giving me x squared minus 2x equals 15. Alright, this becomes a semester 1 problem from here. We went from semester 2 to semester 1. This is a quadratic, and as you know, in order to solve a quadratic, you need to have a 0 on one side of the equal sign. Now from here you've got a couple of choices. To solve it, you could use the quadratic formula, you could factor, you could graph it and see where it crosses the x-axis. My students seem to prefer factoring, so I'm going to go ahead and factor this thing. So I'm looking for two numbers that multiply to negative 15 but add to negative 2, so that'd be negative 5 and positive 3. That means that x equals positive 5 and negative 3. Now, one of my students had this really good idea to double check this thing, and I'm going to steal her idea. What she said to me was, Mr. Alexander, why don't we just type this whole thing, this original equation, into y equals, so log base x squared log base 15 x squared minus 2x, so I've got to divide by the log of 15. And if I go to the table, for x equals 5, it equals 1, which it's supposed to, so 5, I can put a big check mark on that. And x equals negative 3, hey, that equals 1 as well. So both of those are good answers there. Neither of those are extraneous. There's that word again, extraneous. You remember that from square roots? Let me show you one where we do have an extraneous solution. Okay, so I've got log base 4 of x plus 3 plus log base 4 of x equals 1. The whole reason we taught you the logarithm rules, those properties, was so that when we get to solving, you can make your life a little bit easier. That plus sign with the logarithms, we can combine this into one log base 4 if we change that plus sign into multiplication. So I can make this x times x plus 3 inside the logarithm there, because that plus sign becomes multiplication. So I've got x times x plus 3. And of course I can rewrite that, get log base 4 of x squared plus 3x equals 1. Now that I've gotten it down to one logarithm, I'm pretty comfortable getting rid of that logarithm by writing a 4 for the base on both of these, and then I'm going to write the exponent of the original here into the exponent here. Alright, so this 4 and this log base 4 are going to cancel out, leaving me with x squared plus 3x equals 4. And from this point, subtract to get a 0 on one of the two sides. Then I can factor this thing. I'm going to bring it up over here. I need some more space. So when you factor that thing, two numbers that multiply to negative 4 but add to 3, it's going to be, let's see here, x equals 0, so that looks like plus 4 minus 1. So x can either equal negative 4 or positive 1. So now that I've got my solutions x equals negative 4 and 1, I need to double check the very first step in the calculator. I've already typed it into y equals here. Now this is kind of tricky, so be careful. We've got parentheses log x plus 3 divided by log of 4. That's this very first part here. Close that first parentheses. Get the plus sign in there. Log of x divided by log of 4. That's the second step there, or the second expression. When we go to the table, you see I've already got a check mark next to x equals 1, because that one checks. Let's go up to -4, make sure that equals 1. That one's an error, which means this is extraneous, and the only answer is x equals 1. Why is that? What happened there? Well, how did we get an extraneous? Well, think of it this way. Right here in this first step, log of 4, let's just type that in. Log of -4 divided by log of 4. That's a non-real answer. Why? Because, check it out, you can never take the logarithm of a negative number. Think about the domain of logarithms. It's x is greater than 0. Cannot be taken a logarithm of a negative number. That was the issue right there. I've got time to do one more. And the one I really want to show you is the one with natural logs, because for some reason natural logs scare people, but they shouldn't scare you, because you're a smart person. The natural log of x squared plus 15 over 2 plus natural log of 2 equals natural log of 11x. These are just logarithms, so I'm going to combine them. Natural log of 2 times x squared plus 15 over 2 equals natural log of 11x. I'm going to multiply that through to get natural log of 2x squared plus 15 equals natural log of 11x. Now, the base of this logarithm is an e. Log base e is the natural log, so I'm going to write a base e on both of these. And then this is where the magic's going to happen. 2x squared plus 15. The e and the natural log will cancel each other out every time, and oh, look at that, all of my logarithms are gone. We've gone from semester 2 to semester 1. We're back to quadratics. Alright, so I'm going to solve this quadratic. 2x squared minus 11x plus 15 equals 0. And this is a quadratic that gets people screwed up, so I like to use the box method to get myself in the right spot here. I'm going to write the 2x squared right here. I'm going to write the 15. 2 times 15 is 30. So 30. I need two numbers that multiply to positive 15 but add to negative 11. That means they both are going to be negative. So negative 15 and negative 2, that's not going to get me there. Negative 6, negative 5. Oh, there it is. Yep. Negative 6, negative 5. So I'm going to write negative 6x, negative 5x. What's the common factor here? We got an x. We've got a negative 3. We've got a 2x. We've got a negative 5. So to factor this thing, we've got 2x minus 5 and x minus 3 equals 0. So when I set that equal to 0, I'm going to get x equals 5 over 2. And when I set that equal to 0, I'm going to get x equals 3. And again, we need to double check both of those answers, so I'm going to go to the calculator. I'm going to do and the nice thing about natural logs is you don't have to change the base because there's a natural log button. It's right there. So I'm going to type natural log of x squared plus 15 over 2 is just 7.5. So I'm just going to change to 7.5. Natural log of 2. Problem is over here I've got this 11x over here. So I'm just going to go to y2 and I'm going to type in the natural log of 11x, and when I go to the table I'm going to make sure that they are the same. So let's start with x equals 3, and sure enough they are exactly the same. I'm going to put a big check mark at x equals 3, and then I don't see 5 over 2, so I need to go to the table set here. I'm going to change it to 0.5 for the delta table so that I can check 2.5 because 5 over 2 is just 2.5. I'm just going to make sure these guys are the same at 2.5, and hey, look at that, they are. Feeling good about both those answers, nothing's extraneous, and that's it. That's how you're going to solve logarithms. Not too bad, a little bit of algebra. Thanks for watching, hope it was helpful. We'll see you next time for solving exponentials.